Hello, RubyGalaxy. I'm really excited to be able to talk to you about Git Rebase, especially the Git Rebase workflow, and how you can use that in order to make high-quality Git commits, but also construct a well-reasoned implementation, a Ruby implementation, in which to share with your team for code review, or just basically have that history for your past self to empower your future self. So there are several benefits to the Git Rebase workflow. The first is that it's linear, that commits happen one after another, which makes them very readable, so you can understand how the implementation was put together, and it kind of tells a compelling story of how you got to where you are. And then on top of that, it makes it very debuggable, because you can break out the big tools like Git Bisect and other tooling to understand if something went wrong, where that happened, and how to address it really quickly. Before we kind of jump into this though, and we dive a little bit further, I need to do a bit of a review here on the history between merge and rebase. So if you look at the difference here, where we have merge on the left and rebase on the right, and if each one of the circles is a commit and each color is an author, we can kind of walk through this together, where we have a commit happening here in time on the merge and the rebase. We have another commit from a series of commits from another author, and then two more commits from another author. And what's nice about this is you can see very clearly on the right that the rebase workflow is a little easier to understand than the merge workflow. Both are doing the same thing. It's just that it's a lot easier to understand what's happening in a nice rebase linear kind of flowing structure versus a merge structure that has everything preserved in time as it occurred. So what is merge? Well, merge is exactly joining two histories together, and they're just preserving it in time indefinitely. So if you take a look at this and you have the master branch on the left-hand side, and you have three different authors committing code, and then you have this feature branch on the right-hand side where Mariana is trying to make three commits off of Ozzy's commit, and then eventually merge it back into master after Vivian. That's preserved in time, date times, everything is preserved as it is. Which is useful, but it starts to get out of hand if you have a whole lot of merging going on across your team, not just with one author in this case, but multiple authors. So let's take a look at what I mean by that. If we kind of look through a couple examples here, showing a merge history and how that can kind of get out of hand. So if we look at a semi-linear merge history, right, where it's fairly linear, we have like little merge bubbles popping out here and there. But for the most part, it's fairly readable, not too bad. But let me show you another example where here's a team that I once worked on that had a heavy merge workflow. And as we go through time here, you can see that this is getting out of hand really quickly. Like at this point, I can't even tell you who's doing what in the history. We could potentially plot this out, print it out, put it on the floor, map it out, and figure out who did what when. But that's a whole lot of work that we really shouldn't have to do if we were to switch to a rebase workflow versus a merge workflow. Another way to look at this is basically merge, like the definition says, is joining two histories together, right? Well, it's a big mess and a total nightmare to unravel, debug, and figure out who did what when. So I want to kind of emphasize moving away from the merge workflow and focusing on our rebase workflow. By the way, before we continue, I just want to point out those graphs that I was showing you there with the Git Log and the SHAs and printing out those merge bubbles. That was done by using this command. So here I use Git Log, and then I pass graph, the -- graph option to graph out those merge bubbles. And then I pretty print it. So using a format of yellow for the SHA, and then resetting that color, and then starting a green color for the committer date, and then resetting that color is how I was printing those out. These slides, by the way, will be available online, so don't worry if you're trying to capture all this. It'll totally be available for you later. But that's how that's how I was able to generate those Git log histories for you. So now that we've talked about merge, let's talk about rebase, which is basically replaying commits on top of the master branch or whatever branch that you created your feature branch off of. In this case, we still have the same authors, right? We still have Mariana who's doing her work, but she's put her feature branch, or sorry, her commits ahead of everyone else. And when she finally merged that into master, they just show up as the last 3 commits. Again, different authors, same amount of commits, but a much easier to read history. Another way to look at this is, and I'm borrowing these GIFs from Atlassian, but another way to look at this is if the master branch is in blue, you have the commits happening there, and then you have a feature branch that branches off of that, and then eventually gets replayed on top of master. That's essentially what's happening here when you're doing a rebase. If it helps to look at it in a different way, you can just basically pretend that the feature branch that you're working on, when you finally merge it into master, you're just sliding those commits in front of master when you finally commit those changes. So if that helps, that's another way to visualize that. So let's look at a Git Rebase example over the course of many years in this case. Here's a repository in which many commits have been made over the series of months, series of years, and as we speed this up and we go and we fly through the years here, you'll see that this history, using a rebase history, stays linear the entire time. You know, in that other slide where I was showing you the merge conflict, we couldn't even get that far back in time, because the merge bubble would be completely off the screen. So here's a good contrast to show you the difference between the two and how powerful a rebase history really is for readability, debuggability, and understandability in general, for that matter. So what does a merge workflow kind of look like, right? Like, let's kind of walk through this together, talk this through, and then kind of contrast that with a rebase workflow. So for starters, you know, when you start your work at the beginning of the day, you might do a git pull, which is really 2 commands in one, by the way. If you didn't know this, it's git fetch and git merge. That's what git pull is doing. Then you'll start your workflow, right? You'll do a git switch here. You'll create an example branch, and then you'll do tracking. Tracking, by the way, sets up metadata in your git local config for your repository that you're working in, and just ensures that the example branch that you're creating here gets tracked, so that when you push to that remote branch in the future, you don't have to keep typing example each time. By creating your branch and turning on tracking, Git will remember that, and then you don't have to type that anymore. So I highly recommend turning this on, or using this option, I should say, when you're creating new branches. Then, you know, in a typical Git workflow, you'll go ahead and make some commits. You'll make a series of commits. You'll keep doing that until you're satisfied with the work and you're ready to put that up for code review, basically. Then you'll go ahead and maybe you'll switch back to master, right? You'll switch back to master. You'll pull down the latest changes because you want to make sure maybe you've been working on your feature branch for an hour and you want to pull in the changes from the rest of the team, make sure you don't have any merge conflicts. Then you'll switch back over to your example branch. You'll pull from master to make sure that your example branch is also up to date with changes from your team. And then you'll push those changes up and get them up for code review, right? Now, during the course of this, if there's been any changes from the team, you would have merge bubbles at this point in time, because every time you pulled in those changes, and that created a merge bubble. So let's, now that we've looked at merge, let's actually talk about the rebase workflow. So if we contrast what we were just doing in the merge workflow, but highlight the differences, this is what changes when you do a rebase workflow. So instead of doing git pull, what we'll do is we'll do a fetch and a pull. I point out the fetch because what we can do with the fetch is we can prune it at the same time, which will delete all feature branches that you have locally that got deleted on the remote. Highly, highly recommend doing this, and I'll show you how to configure this even further so you don't have to type this out each time. Then the second thing we'll do is we'll do a pull, but this time we'll teach it to rebase. That's it. That is how you switch from a merge workflow to a rebase workflow, is all through this one simple option. Next, we'll do some work, right? We'll go ahead and create our feature branch, make some commits, and then we'll get ready to actually push that work up like we were doing before. What we'll do in this case, though, is we'll switch pull to a rebase. And also the pull, when we switch over to our example branch, we'll do a rebase there as well. So we'll do a rebase origin master. Pull in those changes, but we'll basically replay our commits on top of the whatever changes came down from master when we did the pull. And then the last thing we'll do is we'll go ahead and push these changes up. But because Rebase changes the SHAs, that means that we have to do a force push, which I highly recommend never doing, because it can be very dangerous, right? You can accidentally override work on your feature branch, or maybe if you're collaborating with somebody else, you might overwrite their work. What these two options here do is force with lease will ensure that if changes are happening on the remote that you weren't aware of, in some case, this situation can happen when you're pairing with somebody and you didn't communicate properly and they pushed up changes to your feature branch, the same branch that you're working on, and you do a force push. If you turn on force with lease, at least would detect that and halt that process. So you could be like, oh, wait, maybe I should go talk to my colleague. The force if includes is a new feature, and we'll talk about this a little bit more in a few slides, in the latest version of Git, which basically just does a double check, to put it very simply, that the SHA at the tip of the remote branch is actually in your history currently. And if not, it'll halt that. I won't spend a lot of time on this, but I do want to emphasize turning these on or using these when you do a push with a Rebase workflow. It'll save you a lot of pain and hurt in case you're collaborating with others or forgot to communicate properly. So moving on from there, let's talk about a few Git configuration quick tips. The first is, like I was saying when we were typing this out together, there's a few things you can turn on so you don't have to type so much. One of the first things to do is edit your global Git configuration and set Rebase to true. What this does is this prevents you, so you don't have to type git pull -- rebase every time. You can just do a git pull like you normally do, but now it'll rebase properly, which is awesome. So that's how you turn that on. For every time you pull, you'll always be rebasing. By the way, the command line for this is down below in case you want to turn this on through your global Git configuration. The other thing you could do is you can also update your rebases to be merges. The reason I point this out is you'll need Git 2.22 or higher, but this helps you if you're in a hybrid situation where half your team's rebasing, half your team is merging, and you want to do a rebase workflow because you understand the value of that, but not all your team is there yet. This would allow you to rebase, but also handle those merge bubbles when they get kind of complicated. Hopefully you're not in a situation like that, but it doesn't hurt to have this turned on, and I highly recommend doing that. You can also read up on the Git documentation on how this is used as well, and I recommend spending some time there looking at it. The other thing you could do is the fetch prune, right? When we were doing the fetch earlier, I was showing you how to do -- prune to prune those feature branches that you don't need locally because they've been merged into the remote branch or the remote repository, right? Well, if you set this to true, you don't have to type git fetch -- prune each time. You can just type git fetch and it'll do the pruning for you because you've configured it globally. So highly recommend turning this on as well. And again, this is the command line that you would run in order to set that flag to true within your global Git configuration. Lastly is Git configuration, the push configuration for your global configuration. So use force includes is what I was telling you about earlier. If you don't want to type that out each time, so this requires, by the way, this requires Git 2.30 and higher to actually enable. But when you enable that, you don't have to type this long command line out anymore. It's still kind of long, but you don't have to type out the force if includes anymore because you've turned it on. So I highly recommend turning this on too. It's just a nice way for Git to do that detection for you and save you some time if it determines that things are not properly synchronized up. Or changes have happened on the remote branch and you're about to force push, you won't override any work. And by the way, this is the command line to turn that on globally if you need it. So we've talked about the difference between merge and rebase at this point, and we've also talked about some good configurations that you can apply to your global configuration to help your rebase workflow. Now what I want to do is actually go through Interactive Rebase itself and actually talk through the various commands. So the basic way to do this is just git rebase interactive master and you're off to the races. That's the beginning of rebasing your feature branch on master in this case, assuming that you created your feature branch off of master to begin with. By the way, if you don't want to type in interactive all the time, you can always do -I, and that's the same thing, just shorter. When you do that, what's going to happen is with that interactive rebase, you're going to see this in your editor for the first time. You're going to see interactive rebase pop up, and it's going to say, hey, look, I have 3 commits here. I don't know what you want me to do with those, but here's all the, I'm going to show you that I'm rebasing this SHA onto this other SHA. And by the way, here's all the commands you can give me in which I can do something with. We're going to walk through all those, except for those last 3. The label, reset, and merge are more specific to kind of a rebase merge hybrid. And I'm not going to spend time on that today because I want to stay highly focused on the rebase workflow. But before we get into those commands, I want to pause for a moment and just talk about the various ways in which you can interactive rebase. The first is you can interactive rebase back by a series of numbers, or a series of commits, I should say, sorry. So in this case, with the @number, you can go back like 3 commits, you could go back 5 commits, 10 commits, you name it. However many commits on your feature branch you want to go back, you put in that number and it'll rebase to that point. The one thing that you want to do though is make sure that the number is never higher than the number of commits on your feature branch. What I mean by that is if you go back, if you have 5 commits on your feature branch and you go back to 6 commits, that means the 6th commit is actually a commit that was on master, and you'd be changing the SHA at that point, which means that you can't merge your feature work into the master branch once it's been code approved, or sorry, through the code review, it's been approved by the team. So just be aware of that when you're rebasing. Just don't go back past the commit in which you actually created the branch off of, if that helps. By the way, you can use the @ symbol, but you can also type out head if you want to. I'm showing you the shorthand, but you can also type out head if you want to. They're just synonymous, and that's another way in which to go back a certain number of commits. The other thing you can do when you're interactive rebasing is go interactive rebase by a particular branch name. This is super handy when you're in a situation where you're rebasing, you've pushed up a feature branch for code review, but now you need to continue on additional feature work, which is based off of the stuff that you already have in code review. So you might branch off of that feature branch. So you'd have a master branch, a feature branch, and then another feature branch that branches off that feature branch. In that case, what you want to do is you don't want to rebase all the way back to master. You want to rebase off of your current feature branch off the feature branch you just created. And this is a way to do that, which is super, super handy. The other thing you could do is, like, let's say that you've released a tag and you want to actually create a feature branch off that tag and then rebase off that tag until you can get that hotfix or patch release out. This is a nice way to do that. You can also rebase by a particular SHA. So in the very first slide, I was showing you where you could rebase by a particular number and go back in time. Well, if you don't want to do the counting in your head, you could just select the SHA that you want to rebase back to, and interactive rebase will go to that SHA, let you rebase from that point, and then complete the rebase workflow. So that's a really handy technique to have. You can also rebase by upstream. So this special syntax here allows you to rebase by changes that are happening upstream. I personally don't use this much myself. In fact, I can't think of a time that I have had to use this. But it is there for you if you ever needed to do something like that. And so I just want to point that out to you. The last one here is being able to rebase by root. And this is one of my favorites. It is super powerful and really awesome. But it does come with a big, big caveat. When you rebase by root, you're basically going back to the very first commit of the entire repository. And you might be thinking, hey, why am I even telling you this? That sounds extremely dangerous. Well, it is on an existing code base that you've shared with your team or you're collaborating on with others. That would be disastrous. You don't want to rebase to root. But in the scenario where you're creating a repository the first time, maybe you're going to open source it and share it with the world. Maybe you got an internal project that you're doing some work to get into the right state before you release it for others to collaborate within your company. This is a wonderful, wonderful way in which to rebase, clean up your code, clean up your commits, tell a compelling story, and show everyone how you built up your implementation before you share it with them. I do this all the time when I'm releasing new projects or open source work. Highly, highly recommend, but only when the repository has not been shared with anybody would you want to use this. There's also an advanced technique when you're rebasing to basically disable the editor from popping up every time. And the way to do that is basically put git editor true in front of your rebase command. And that'll, I know it sounds kind of counterproductive or counterintuitive, right? Because you're saying true, you maybe want to say something like false. But if you set it to true, that'll disable the editor from popping up. And this comes in really handy when you're doing a lot of fixup commits, because when you're rebasing and you have fixup commits, you can just let Git figure out where those fixups should go and don't prompt you, because there's nothing for you to do as an author. So this is a really, really handy technique and great to have in your arsenal when you're rebasing heavily and really quickly. So let's talk about the Git Rebase Editor. Let's jump into these commands and kind of walk you through each one of those. And I want to focus on all of these right here today and kind of give a brief overview and show you how to use them if you've never seen them before. I also want to point out that you can write these out every time, or you can use the shorthand and just not type out pick every time. You can just use P or R or E, depending on whatever command you want to feed the Rebase Editor. So let's start with pick and actually explain how that works. It's the default thing that you'll see when you're first rebasing. It seems kind of boring, but it actually has kind of a superpower. And what I want to point out is when you look at, let's say that we have 3 commits on our feature branch, and we want to reorder those. Normally with pick, it's kind of a no-op in the Rebase Editor. If you just pop up those commits in your Rebase Editor and you don't do anything with them, you just leave them as picks, then it's kind of a no-op. There's really no rebase happening. But the nice thing is you could actually reorder these if you want to tell a more compelling story. So in this case, we have an initial implementation, we added documentation, and we fixed the JSON schema. Well, if we want to make a good compelling story here, kind of read like turning a page in a book, we could reorder these 2 commits here, the last and the first, just like this. And now the fix happens before we added the implementation and added the documentation. So now we're telling kind of a different story here on how the evolution of this implementation came to be. The next thing we could do is we can also reword commits. So when we reword a commit, what we do is we change pick. In this case, we'll pick this middle commit. We'll change it to reword. And then what's going to happen is this is going to pop up in our editor and allow us to not only reword the subject, but also the body. And this is a nice way to fix like a typo, explain ourselves better in the commit message, all those things before we commit the code to our master branch or go through code review, whatever. This is a nice way to clean all that up. So in this case, we can fix the subject. We could rewrite it this way so it's a little bit more descriptive. In this case, we're saying exactly that we added the table of contents to the README, which is way more descriptive than what it was. And then we can also fix our subject or our body if we wanted to too. What's really nice about this is when you have a subject and a body, the subject is the what. It explains what it is that you're committing. And then the why explains why you did what you did, right? It supports the subject to explain what your thought process was at this point in time in committing this code. Very, very, very powerful. So if we use a Git log here, we do a pretty format of what we just reworded. Here's what those commit messages look like. And you can see the middle commit is where we reworded that commit, and it has the new subject, which is exactly what we want. So if we move on here and we get into a little bit more of the advanced tools, edit is one of those. And I won't be able to show all of this to you today, but if you haven't noticed so far, and I apologize for not pointing this out earlier, is in the footer of these slides, I have links to screencast tutorials in which you can actually dive into each one of these commands a little bit deeper and understand them even fuller. Because I just don't have enough time in this slide today to actually explain everything. But I just want you to know that you can look at those screencast tutorials for additional work. And this would be one of them that you'd want to dive into a little further. So I'll explain kind of at a high level what edit is doing. In this case, we can change like one of these picks to an edit. And all we would do is just reword pick to edit, and we're off to the races. What'll happen in this case, though, is during the rebase, Git will halt at that edit SHA that you wanted to edit, and you can do a multitude of things. You can fix up your implementation, you can rerun your specs if you wanted to, You could edit your subject, your body of the commit message, you name it. When you're finally happy with those changes and you commit those, then you can do a git rebase continue and continue on with the rebase, and you're done at that point. So edit's a nice way to go back in time in one of the commits on your feature branch and just basically correct them, both in terms of commit message and implementation. Really, really powerful tool. The other thing you could do is you can squash a commit. And what squash does is, in these 3 commits that we've been looking at so far, we could take 2 of those and we could actually squash those into the previous commit. So in this case, we would change those 2 commits to squashes, and then they would just squash themselves into the previous commit. Now, what squash does though in that case is it takes all 3 of those commits, the subjects and the bodies from all 3, and smashes them together, and it wants to make one big commit message by default. You don't want to do this because as you're reading this here, this is kind of a mess to read through. It's a lot to decipher. There's 3 different ideas going on because we're squashing 3 commits into one. So what we can do is Git Rebase will halt in the editor with those 3 commit messages all squashed together, and now we can fix them up. And the way to do that is we can go ahead and kind of look at our subjects, we can look at our bodies and be like, hey, you know what? We can actually write this a little bit better. First of all, we can throw out that we fixed the JSON schema because we're squashing them all 3 commits down into one commit. So the fact that we had a screw up, we could just make that magically disappear as if we hatched it perfectly the first time, which is a nice little trick. The next thing we can do is we can get rid of this middle subject. It's not really helping us in this case. We can kind of just sort of reword that a little bit. So what we can do is collapse that down, have our 2 subjects now, and then this last body. Now we're starting to get kind of to the meat of things here. This is starting to tell a more compelling story. So we like the subject, but these two paragraphs here are not really working for us. So let's just tear out this first line and reword this so that it actually reads better as a paragraph. And that tells a more compelling story. Now we have a clear subject and we have a clear body and a nice commit message that summarizes those 3 commits that we just squashed down into one commit. This is a really nice way to use squash. The other thing we do is we can do a fixup. Now, fixup is like squash, but it's a little lighter weight. It's actually one of my favorite commands. I use it all the time. And to show you, it works the same way as squash. So in this case, we'll take pick. We'll pick a couple of these commits, right? We'll make a fixup, and we're going to fix up this commit into one of the other commits, right? So we'll move that fixup here to the first commit, and that's going to take that middle fixup commit and just fix it into the previous commit. What's going to happen though is the subject and the body of the fixup commit is going to be thrown out in favor of taking the first commit's subject and body. What we're fixing is really the implementation, not the commit message in this case. That's the big difference between squash and fixup. But super, super handy when half the time you are just wanting to fix up your implementation. This is a great way to do that quickly without having to re-edit your commit messages each time. So now if we run a Git log on the Git commits after we've done our rebase, we'll see that we only have 2 commits instead of 3 commits now because we fixed the first one into the previous commit, which is really, really nice. So we can also execute code when we're rebasing, believe it or not. Execution is a nice way to run additional tests, scripts, maybe some diagnostic tools in between our commits when we're doing a rebase. It's a really, really powerful tool, but I'll just touch on it briefly today and let you kind of experiment and go wild with it after. So the way this works is exec works a little differently than all the other commands where we've been renaming pick to whatever command we want. With exec, we actually have to slip it in after the commit that we want to do something with. So that middle commit that we were just looking at, we'll put the exec script after that commit and then run that script. So in this case, I'm doing a kind of a very simple contrived example where I'm just going to print a string, which is called this is an example script in this case. And that's going to run in the middle of the rebase right after that second commit, but before we actually finish our rebase with the fixed JSON schema, that last commit. And what it'll do is it'll just spit out that text in the command line. It's just a simple print command. I know this is very simple, but imagine if you wanted to run like your RSpec test suite, or maybe RSpec on that particular implementation, or files that were changed in the previous commit, or any other kind of diagnostics that you might want to run. The sky's the limit on what you can do here. And also in this case, I've only shown you running a little simple script within the Git Rebase Editor. There's nothing stopping you from actually having a bash script and just executing the bash script here too. So sky's the limit on what you can do with this command. Moving on actually is another command called break, and this is recent. I forget which version of Git this was added in, but it's a nice way to actually kind of put a debug statement in the middle of your rebase. It works a lot like exec, but it doesn't actually execute anything. It just halts your rebase in the middle. So again, if we take this middle commit, right, and we put a break after that, what will happen during the course of the rebase is it'll start rebasing those first two commits, and then it'll halt at the break, and then just kind of hang out waiting for you to continue the rebase. You'd have to do a git rebase -- continue at that point to continue the rebase. But break, by the way, is just like I've been saying, it's just a great way in which to kind of do a breakpoint in the middle of your rebase. Maybe you want to add more commits. Maybe you just want to look at your implementation at the commit that it broke at. You know, sky's the limit on what you want to do, but it's a nice technique for debugging rebase. Finally, the very last command is drop. And it's really simple, almost as simple as pick, except the only difference is that when you change something to a drop, it's actually going to delete that commit entirely. The commit message, the implementation, everything with that commit is going to be deleted. Technically, it's not completely gone if you screwed up. It would actually be in your ref log, but I don't have enough time today to actually dive into the ref log for you. But that is what's happening, is it's deleting that commit. If you don't like to type a lot like I do, you don't actually even have to type out drop in this case. The other way to drop a commit is basically just delete the line that you don't want. And when you save and let Rebase finish, it'll delete that commit just as if you'd physically typed out drop, which is another cool way to drop commits that you don't want. So if we look at the Git log again, and after our rebase, you'll see that we only have 2 commits left, right? We dropped the middle commit, and that's exactly what we wanted in this case. Okay, so we've gone through all the commands. Now I want to talk about Git Rebase Resolution. This is basically what you have to go through when you are doing a rebase and you have a merge conflict, and what do you do in that situation? So the very first command is being able to abort. Any point in time when you're rebasing, if you get scared, you're nervous, you're not familiar with Git Rebase, or maybe things are just, the merge conflict is so gnarly that you don't know what to do with it, you can just abort at any time, and it just rolls back the commit, or sorry, the rebase. It's as if you didn't do the rebase to begin with. So this is your escape hatch, a really cool command if you in the middle of a rebase and you just want to start all over. If you're also in the middle of a rebase and you hit a merge conflict and you resolve it, when you want to continue the rebase, this is how you continue it. Same thing like I was saying before, if you were doing a break or you were doing a rebase with an execution or an edit and you needed it somehow halted the Git rebase, this is how you would continue. In certain circumstances when you're rebasing, sometimes rebase will just stop, but it actually doesn't have anything to do. It just kind of halted at a place where it resolves something, but there's nothing for you to do with the Git rebase. So in that case, you can just happily skip and continue on with the rebase. You're basically just telling rebase to continue on its merry way. The other thing you could do too is maybe you're in the middle of a pretty complicated rebase. Like maybe there's like 10 commits on your feature branch. You had a couple merge conflicts, and at a certain point you just kind of forgot where you were in the rebase flow. Well, in the middle of a rebase, you can always do Git Rebase show current patch, and that'll give you the diagnostics of where you're at. It'll show you what SHA you're on. It'll show you a diff of the current SHA that you're on, and you can kind of get a sense of where you're at, which is really nice. You can always use Git status as well, but I kind of like Git show current patch because it's a nice way to give you a little bit more insight into the actual rebase that you're doing. Both will work. I just kind of like this one a lot better. Now we've gone through all the commands for rebasing. But there are a couple special ways that you can do rebasing a little bit differently using commands that you're probably a little bit more familiar with, which is Git Commit. If you didn't know, you can also pass a -- fixup into Git Commit with the SHA of the commit you want to fix. So let me show you what that looks like. So if we look at our Git log and we have these 3 commits that we've been talking about, let's say that we want to fix up one of those. Like let's say that the initial implementation isn't quite the way that we wanted it, and we wanted to make a few changes to the files in that initial implementation. Well, we could edit those files, make those changes, commit them, but this time commit them not making a new commit message, but instead making a fix-up commit message for that particular SHA. So all we have to do is just pass the SHA to fix-up of the commit that we want to fix. And then we can pick this second commit and say that we want to fix it too, and update the implementation there as well. So what that looks like in your Rebase editor, if you do a Git Interactive Rebase and you rebase off a master, you'll see this in your editor. And if you've never seen this before, it's just, you've got 5 commits here instead of the 3 because we did the commit with the -- fixup command. And what Git does is it creates a fixup bang command, or sorry, a fixup bang commit with the same subject as the commit that you want to fix up. So in this case, the way that Git does this is it associates the subjects together and makes it so that you can easily fix things that you've told it to fix up in the previous slide that I was showing you, where we were doing a Git commit with a fix-up. So the way that Git does this is it's very simple. It just makes a fix-up bang, and it uses the subject of the commit that you're trying to fix up. The reason I highlight this is because you don't want to reword at the same time you're fixing, because if you rename the commit that you're trying to fix, the fix-up won't actually know where to associate itself. So try not to do that when you're doing a fix-up. The other thing too here is normally these fix-up bang commits will show at the very bottom of your commit history. So instead of having them intermixed like you see here, because I have some advanced features turned on, Git wouldn't normally do that by default. You'd have to physically move those fix-ups to where you want them to be. I'll show you how I have this turned on and how Git did this automatically in a few more slides, but just be aware that that's what I have turned on here. And then again, in the second commit, the reason Git was able to associate where the fix-up needed to go with the original fix-up, or sorry, the original commit, is through the subjects. Both those subjects have to match. That's how Git is basically doing that calculation. Now, when we save this and we rebase and we do a Git log here, we'll see that those fix-ups magically got merged into the previous commits, and our fixes are in place, and it looks like we just have those 3 commit messages from before, except this time they're fixed properly the way that we wanted to, which is exactly what we wanted, and a nice way to kind of sort of massage and make those fixes and screw-ups that we caught while we were doing our feature branch work before we actually get it up for code review. So just like fixup, you can also use squash. It works the same way as fixup, except when you do a Git rebase right, it's going to halt and allow you to edit your Git commit messages. That's the only difference, but the flow is still the same. So if we look at our Git log, we look at these 3 commits, and let's say that we want to squash one of them. We just put it in the SHA like we do with a fixup, and then what that's going to do in your editor is it's going to halt, and it's going to say, hey, look, these 2 commits here, they're going to be squashed by the subject, and in this case, the Rebase editor will halt and then allow you to edit the commit message at the same time that it's squashing it. Same thing as the fixup bang, except that you get to edit the commit message in this case. That's the big difference. So now that we've gone through those 2 techniques, which are really handy from the command line, the other thing I want to mention is amend. You might actually be pretty familiar with this, especially if you've done a decent amount of Git work. This is a pretty common tool to be aware of. But I want to highlight a few things for you. Amend, by the way, always amends the last commit, and it's a great way to edit that last commit really quickly without having to launch the entire Rebase editor, because that would be too much work. What you can do, though, is you can pass in -- no edit to amend your previous commit, but don't pop up the editor. The reason I point this out is this is really nice for situations where you've made a change to your implementation, but you really don't need to pop up the editor. You don't need to change the commit message. So this is a fast way to do that. The other thing you could do is you could also pass in -- all, and that'll allow you to kind of slurp up everything that you're working on and throw it into that last commit. Granted, you still want to keep your commits atomic, right? Just implementation plus spec if you can. So keep it really tight, very clean. But if there's a lot of changes because you're doing a refactoring or there's a bunch of things all related, this is a great way to kind of grab all that, throw it into the last commit without even popping up the editor, which is a really fast workflow. So let's talk about a few more Rebase tips, a few things to actually power up and make your workflow and Git Rebase workflow a lot more easier and pleasant. There's 3 commands that I highly recommend that you turn on in your global Git configuration, and let's walk through each one of them. The first one is abbreviate commands. If you turn this on to true, that'll change the Git Rebase editor from typing out the long form of pick and reword and drop. It'll just change them to their single letter equivalents. So instead of PICK for pick, you just have P, D for drop, and R for reword. Highly recommend turning this on once you get familiar with the Rebase workflow and you don't want to do all that typing. Auto squash, by the way, is how the squash bang and the fixup bang were showing and aligned next to each other in the commit editor, Git Rebase Editor, when I was showing you in the slides previously. By turning this on, Git will figure that out and align those subjects together so that they're nicely they're put where you want them to be. If you leave this off as false, that means that you have to manually do that movement yourself. So highly recommend turning this on. And the last one is auto stash. Auto stash is wonderful because normally when you rebase, if you have anything dirty in your working directory, the rebase will halt, will actually not start because it wants you to do something with those files, either commit them or delete them or stash them. So normally you would just stash them manually yourself. But what auto stash true does is before the rebase kicks off, it'll detect those changes, immediately throw them into stash without even prompting you, allow you to do the rebase. And then when the rebase is complete, it'll pop the stash and put you back to where you were working. It's a really awesome workflow and highly recommend turning on just to let Git figure all that out for you so you don't have to manually do it yourself. And by the way, these are the command line arguments or the commands that you would type through your shell if you wanted to enable this globally. Okay, one last thing that's really powerful to configure for Git Rebase, which is Git re or rear. I can never pronounce it properly, but it's really nice to have turned on as well. So first of all, you want to enable it, and what that'll do is that'll basically during a rebase, it'll any conflicts that you resolve, it'll record and stash those conflicts into like a small patch set and replay those anytime you do a rebase in the future, so that you don't, once you've resolved the conflict resolution, especially if you're rebasing heavily constantly, you're working on your feature branch for a long time, a lot of changes are coming from your team down upstream. As you resolve those merge conflicts, you don't want to keep having to resolve those every time you rebase. It's kind of a pain. In those cases, you can teach Rebase to remember those merge conflicts and attempt to replay those when it sees that it can actually do that automatically for you. So highly recommend enabling that. The last thing here is auto update. If you turn this on, it's off by default, but if you turn it on, when you resolve those merge conflicts and you make any additional modifications to them, Git will also remember that as well and try to replay that information as well. So as you get better at your rebasing and merge conflicts and resolving those, basically re is a nice way in which to teach Git to also remember those changes and try to do that work for you if it detects it. And again, these are the command line. This is the command line that you want to run if you want to enable this globally. Highly recommend turning this on. It'll save you some work. Okay, so now that we've gone through the Rebase workflow, we've talked about the difference between merge and Rebase, how to use Rebase, how to configure Rebase. Wouldn't it be awesome if you had a coding buddy, an automated little bot that could hang out with you and help ensure that your Git commit messages are really well written and well formed? Well, Git Lint is a Ruby gem that I've developed that actually makes that possible. What it does, and we won't go into all the details here, but I'll just kind of gloss over it briefly, is it'll help you make sure that you have properly capitalized prefixes to your subjects. It'll make sure that you have correct punctuation, make sure that you have a space between your subject and your body so that they're not smashed together and they're easy to read. It also makes sure that you have like a nice 72 character limit so that you don't have horizontal scrolling in code reviews, so that they're easy to read and they're nicely word wrapped. And it does a ton of other things, and I won't go into that all today. But to install it, it's very simple. Just do a gem install. You can check out your project, switch to your feature branch, and then you can analyze it. And by default, Git Lint will analyze a feature branch. It won't do anything on your master branch because once the code is on your master branch, you can't really rebase that, or you wouldn't want to anyway. Your team would be very upset with you if you did. But you can analyze it that way, and that'll tell you whether your Git commits are of sound quality. There's also plenty of ability to wire it up as a Git hook so that Git Lint is always running every time you make a commit. You can even wire up CI support. On my team, we actually use it as a GitHub action. So tons of ways that you can configure Git Lint to actually work for both you locally through Git hooks or via your team in a CI environment. So what are the next steps, right? We've gone through Git Rebase, we've talked about the flow, the configuration options, and even using Git Lint as a tool to help make your commits better. Well, the first thing you can do is start your workflow and just focus on it every day. Just take a little bit. Take some of the commands I was telling you today, work on them bit by bit, keep getting better and better and exercising that mental muscle until it just becomes second hand. And then this will become easier and just a natural part of your workflow without causing you any grief or pain. The other thing you can do is a lot of those commands that I was typing out and showing you, it's a little bit to type, right? So if you can make an alias or a function to automate that even further, I highly recommend doing that. And I have a link here to my .files project in case you want to see additional examples of how I alias things, how I write functions, and just make this workflow really hum along so I don't have to do a whole lot of typing. And then lastly, consider adding Git Lint to your projects, right? Let it be a coding buddy to you, but also to your team in order to make those Git commit messages tell a good, compelling story so that your history is linear, debuggable, and easier to read, not only for your future self, but also for your fellow colleagues. In case you're traveling on vacation or not even with the company anymore, they'll have the joy of being able to understand what it was that you were doing at that point in time when you were implementing that code. And that's a really good feeling to leave behind as a legacy of your work for others to enjoy. And that's it. That's my Git Rebase talk kind of in a nutshell. I know that's a lot to go through. There's plenty of screencast tutorials, long form articles on the Alchemist Collective website there. Highly recommend checking this out. I'll have my slides up there as well. And all the links and everything that was in this presentation will be there for you to enjoy and dive as far as you want to into this rabbit hole. Thanks so much for everyone allowing me to speak at RubyGalaxy. I hope you enjoyed this, and I will see you online.